Alright, so we're connecting various forms of the equation of a plane. The first one, they've given us a equation of a plane, but in vector form, and they want us to put it in, Cartesian form. Okay? Now, Cartesian form, if you guys recall, ax plus by plus cz plus d equals 0. Also, the normal coordinates of the projection vector for the normal are a, b, and c. Since the normal is perpendicular to this plane, what we can do is we can take our two direction vectors. We'll take our two direction vectors and we put them through the cross product. The cross product will give us a vector that is perpendicular to this plane. And then from there, we just plug in points to figure out what our D value is.
Ms. Forrester, please contact the main office. Ms. Forrester, please contact the main office.
What we're going to do is we're going to find the cross product of these two. We'll call them direction vector M and direction vector N. So we're going to find M cross N. And when we do that, that's going to be our A2. Actually, since this is our... We'll rewrite the two of them. 1, 0, 2, and negative 1, 3, 4. We'll call this N is our second, and M is our first. If you guys remember cross product, should I write it out again for you? B3, A3, B2, subtract A3, B1, minus A1, B3, A1, B2 minus A2, B1. So, our A2 is 0 times B3 is 4. Subtract A3 is 2 times B2 is 3. A3 is 2. B1 is negative 1. A1 is 1. B3 is 4. A1 is 2, is 1, B2 is 3, and A2 is 0, and this should just say B3. Sorry, B1. B1 is negative 1. So we get 4 subtract 6 is negative 2, negative 2 subtract 4 is negative 6, and 3 subtract 0 is 3. So our normal, or a perpendicular vector, is negative 2, negative 6, and 3. We can plug that right into our Cartesian form because this is our A, our B, and our C. We get negative 2x minus 6y plus 3z plus d equals 0. We then have to take 1 point. Is one of them done? Oh yeah, sorry. Thank you. That is negative 6. Sorry. That was 0 subtract 6. I think I did 4 subtract 6. Good. What was it? Oh yeah, we get a point. So, a point on this plane in Cartesian form. Well, this is one of our points along the plane. 1, 2, and negative 1. So we're going to take 1, 2, and negative 1. And plug them in for the x, y, and z. Negative 6 times 1 minus 6 times 2 plus 3 times negative 1 plus d is equal to 0. Negative 6 minus 18 plus 3. I feel like that's very different from what they got. Oh, let's see. Now, because I had this as a different number before, what we can do here is our Cartesian form, we usually want it as a minimal vector as possible, so a scaled down simplified vector. So I can take out a scalar here. Now, if I'm taking out a scalar of it, it's fine. It doesn't matter if we do it this way or not, and we're going to show that. Let's say I took out the number negative 2 in this. If I take a negative 2 out, my A value would have been 3, 3, sorry, not negative 2, negative 3. 2 is not a factor of it. If I take a negative 3 out, we would have had 2, 2, and negative 1. Okay? Just on the other side, we'll show this. That would have given me 2x plus 2y minus z plus d equals 0. Okay? Again, we would have had 2 times 1 plus 2 times 2 minus negative 1 plus d equals 0. Okay? This gives us 2 plus 4 plus 1 plus d equals 0. D is negative 7. And in this one, what do we get? 4, 21. D is positive 21. I'm really working on my math today. That gives us negative 18 plus 3 is 15. Is that right?
Yeah. Negative 15. Because it's negative 18 plus 3.
Math issues here. Okay, let's go over my multiplication skills. So, negative 6 times 1 is negative 6. Negative 6 times 2 is negative 12. 3 times negative 1 is negative 3. These all add up to negative 21, which means D is 21. So I just found it a different way in the first place. Now, if you notice, the D values are both different, but there's a reason for this, and we're going to write the 2 out again. Negative 6x minus 6y plus 3z plus 21 equals 0, along with 2x plus 2y minus z minus 7 equals 0. Okay? These look like two very different questions, but if I take the first one, or sorry, the second one, and I multiply it by negative 3, I end up at the second one. It's a scalar multiple of the other. So whether I decided to factor out that negative 3 when I was looking at the direction vector for the normal, and that's this process here, whether I decided to take that out or not, I still end up with the same Cartesian form, just one of them is a larger version or a scalar multiple of the other. Both are technically right.